In a simple pendulum, we have a bob attached to a weightless and inextensible string which is attached to a rigid support. If the bob is displaced from its equilibrium position, its motion will be simple harmonic. If I consider the mass of the bob is m and the length of the string is l and the angular displacement is theta, then the motion will be simple harmonic and we can prove it mathematically. Let's go. Let the bob be displaced through angle theta. Then various forces acting on the pendulum when it is at extreme position E. Number first, the weight of the bob which will be in downward direction mg. Alright. And now there will be a tension in the string which will be along E1P. So the various forces are, number first, tension in the string, tension in the string along E1P. Number second, weight mg in downward direction. Alright, this weight can be resolved into two components. Alright, let's see the two components. So this weight has two components. One will be horizontal component and one will be vertical component. That means the weight mg which is along E3 can be resolved by taking the right angle triangle E1, E3 dash and E4 dash, draw perpendicular here. So in this right angle triangle we will have sine theta equal to E3 dash E4 dash to its hypotenuse E1 E3. Okay, so E3 dash E4 dash or E1 E2 is mg. Then this is the component of mass. Sorry, this is the component of the weight. This is the vertical component of force. Let me write it as F1. It will be mg sine theta. And the direction of this will be towards the origin. Oh, it will be towards the origin. Alright. Now another will be, if you take this, it will be E1 E4 dash E1 E3 E1 E4 dash. This, suppose this is mg and this is F2. So second component will be, this is another component of weight. This is horizontal component and this force will be along E dash, it will along E1 E4, then it will belong this E1 E4. As the tension is along E1P and the force F2 is along E14, these are in equilibrium. That means this tension in the string will be called F2, which is called mg cos of theta. These two components are equal but opposite. They have nothing to do with the motion of the bob. Alright, so it is the vertical force, vertical component of force F1 which is towards O, which plays the part. This force always tend to bring the bob at its origin. See, when the bob is on the left, when the bob will be on the extreme position, another extreme position, the force, restoring force or F1 will along go. So this force acts as a restoring force. The motion of the simple pendulum. The various forces acting on the bob are given by different colors. Blue color is the weight in downward direction. The green color is the component of the weight which is balancing the tension in the string, and the red color is the restoring force which is always towards its main position. This as F1 as F, which is minus mg sine of theta. Okay, so using Newton's second law, this force is mass into acceleration, which is equal to minus mg of sine theta, or acceleration will be minus g sine of theta. For smaller angular displacements, sine theta is theta, therefore acceleration will be minus g theta. Alright, but theta is y over L, then acceleration will be minus g over L times y. Okay, this acceleration is y double dot minus g over L times y. G over L, say this is omega square, g is constant, L is constant, therefore this will be equal to minus omega square y. Omega square is constant, so you see acceleration is negative times displacement, so we say that this is simple harmonic motion. Okay, in terms of theta, acceleration in terms of theta, as acceleration is minus g of theta, okay, and theta is y over L, so y is theta L, then y dot will be theta dot L, y double dot will be theta double dot L. L is constant, y is varying, theta is varying. Okay, so the acceleration will be y double dot, which is actually theta double dot L, so it can be written as this acceleration will be theta double dot L minus g of theta, theta double dot will be minus g over L times theta. G over L is omega square, theta double dot is minus omega square theta. Okay, so this is acceleration is in terms of theta, and you see acceleration is negative times the angular displacement. Angular acceleration is negative times angular displacement, so it is simple harmonic motion. Time period, as omega is under root g by L, omega is actually 2 pi over t, which is under root of g over L, then time period will be under root of, time period will be 2 pi under root of L over g. So this is the time period of the oscillation of the simple pendulum.